So in this lesson now, we're still working with our exponential equation. We're focusing on what we talked about, whether here we've got that a times b to the t power, where a always represents that y-intercept, b is the base, right? So it can represent growth or decay, right? If that base is less than 1 or between 0 and 1, then it's a decay. But if it's greater than 1, now we have that growth. We're just now going to be solving and applying this in some different problems here. So like this first one, and just to show you and relating it to our graph. So here the amount of bacteria starting at 1500, right? At 8 o'clock in the morning. So 1500 is the start. So see, notice how we have our 1500. And notice here too, it's halfway between 0 and 3000. So there's that y-intercept at 1500. Then it says it doubles each day. So there's our 2 here. That represents after t days. So now t is going to represent our time here. So what is the amount of bacteria present after 2 days? Well, we could go to our graph here. So after 2 days, how many bacteria? 6,000. What is the amount of bacteria after 4 days? So 4 days, 24,000. Now, what if we had the amount of bacteria after 3.25? Now, see, we would have to kind of estimate, right? So it would be somewhere in this range, but we can't really tell. So now we would then calculate, right? So like, for example, if this is our t, our time in days, we're going to use this function. Y is equal to 1500 times 2 to the t power. Well, what is t? T is 3.25. So now put that in the calculator, and y, or the amount of bacteria, is approximately, when you put this in the calculator, you get about 14,270 bacteria, which if we were to look here, 3.25, let's say I'm estimating, right, is right about, yep, somewhere between, so in that 14,000 range. So it makes sense to our graph. So again, notice we can either, again, use our graph here or the calculation. So today we're going to focus on that calculation piece. So like here, example 2. We have a phone that's originally $1,000, right? So that's the start. So if we think about it, that would have been like the y-intercept, so y,1000, but loses 3/5 of its value each year. So there's our 3/5 here, right? Notice decay. After to the t power, because that is our t, time in years. After 2 years, how much is the phone worth? So now 2 is our t. So again, y is equal to 1,000 times, so again, practice putting in the calculator, that is 3/5 to the second power. So if you need to, pause the video just to try and put this in your calculator. And so when you put this in the calculator, you should get that y is equal to, or the phone is going to be worth how much? $360, which makes sense because it started at 1,000, but it's losing its value over time. So now it's going to be worth $360. So go ahead and pause the video now and try the you try on your own. And here we go. So here in 2000, our population started right at 650. So it makes sense here in our equation. That's your y-intercept. That's the start. It increased by a certain percentage, which we're going to talk about after we go over this problem, but it's represented by the equation 1.15 to the t. So here, the t represents years after 2011. So we want to know the population in 2018, which means what do we use for t? Well, how many years have passed? 7 years, right? So this is the population is equal to 650 times 1.15, but now to the 7th power. Notice this is an increase. Our base also represents that, right? See how it's greater than 1, so this is a growth model. And the population is, now you do get a decimal, but if we're talking about deer, can you have a decimal amount of deer? No. So we're going to leave it at that whole number that you get in front of the decimal, so about 1,729 deer is the population. So I'm going to come back to this to explain how we're going to get that percentage here and what this means, because now we're going to change it up a little bit. What if you're given the percentage? We have to figure out what the base is. So notice how here we're changing it up. So now our initial is going to be P. That's what's called our principal. So another word for our initial, P, our principal. So this is our initial, where we're starting, just like the A here. Now, the base was usually given to us, but now we're going to have to solve it given the percentage. And so it's going to be, if you notice, plus or minus, right? Because it could be a growth or a decay. So we always, though, start at 1. So like, for example, we're supposed to start at 1. So this problem actually represents a percentage of 15%, because here 15% is the same as, well, 15% or 15 per 100, right? If you divide 15 by 100, you get 0.15. So 0.15, add that to 1, there's your percentage. So that's how we're able to see the percentage here. So like here, for example, we are given in our first problem that in the last 12 years, so here's our T, our initial population, so there's our P, we started at 38, but now we're given a percentage, 7%. So here we need to first figure out what is our rate. So our rate is 7%, right? But divided by 100, because that's per 100, which is actually 0.07. So that is the rate. So 7%, 0.07. So now we're going to solve for the final amount. So again, A is equal to P times 38, or 38 times 1. Now, this is grew. We're growing, so plus or minus. Plus 0.07, raise that to the P power, which is 12 years. So now here, this is the same as 38 times 1.07 to the 12th power. Notice how here we're back to where we were before. We were always given just like the A and the B. Notice here's our base. Then just put this in the calculator. You get that this is approximately, now we're talking about buffalo. You get a decimal. So can you have a decimal amount of buffalo? No. So we're going to keep the value in front, and there's approximately a population of 85 buffalo. So go ahead and pause the video and try the U-try on your own. And here we go. So you invested, you started at 75,000. So that is our peak for a 30-year CD. Grows at a rate of, so here's our rate. However, remember, right? We cannot leave this as a percent. So per 100, divide by 100, which is 0.125. So this is our R. What will the value be after 30 years? Here's our T. So here we go. A is equal to our initial 75,000 times 1, we're growing, so plus our rate of 0.125, raise that to the 30th power. So now notice this is the same as, this is 75,000 times 1.125. Raise that to the 30th power. Now, This is money, so we can write this as a decimal because this is our money. So our A, our final investment amount, is approximately, so you should have gotten a very large number, right? So $2,568,247.87. So now here, example 4 is a little different. We're still going to read through, but now notice that the population of bears is decreasing. So now we're not going to add the rate, we're now going to subtract the rate. So here our rate is 2%. So again, R is 2 out of 100, right? Because we have to convert that. So it's 0.02, 2 divided by 100. So this is our rate here. Then we have our population of bears. So here's our P where we're starting. How many bears will there be in 10 years? There's our T. So here we go. A is equal to our principal amount where we started, 1,573 bears, times 1 plus or minus now. Minus, right? Because we're decreasing. 0.02. Raise that to the 10th power. So now notice here, this is 1,573 times 1 minus 0.02. Well, that gives you 0.98 to the 10th power. So see now, notice our base is less than 1, which shows decay. There's your decrease. So now put that in the calculator. And again, we're talking about bears. So you cannot have a decimal amount of bears. So the population is 1,285, which makes sense because we started here and we're decreasing. So it should be less than that. So it's the same process, but now we're going to have to make sure to identify if it's a growth or a decay. So go ahead and pause the video now and try the U-try on your own. And here we go. So a car depreciates. So that is another way of saying that it's losing value. It's decreasing. So this is a decay model. Your rate was 20%. So don't leave it percent, right? Divide that by 100. You should have gotten 0.2 now. So that is different from 0.02, right? That's just 0.2. The forerunner started at $45,000. That's the initial amount. What is the value of the car after 4 years? There's your T. So here we go. A is equal to the initial 45,000 times 1 minus, right? Because depreciating, losing value, 0.2, raise that to the 4th power. So now when you get here, you should have gotten 45,000 times 0.8. So again, notice that base is less than 1, showing your decay to the 4th power. So the approximate value of the car is, so money, $16,384. So same thing here, another you try. So go ahead and pause the video and try this you try now on your own. And here we go. So here, the initial amount was $30,000 in 2000. The land depreciated, losing value. So you should subtract because this is decay. 5%. So there's your rate. 5%, 5 out of 100, which is 0.05. So this is our rate. What is the approximate in 2011? So P is equal to 11 years, 2000 to 2011. So you should have set this up as 30,000. That's our start. But then times 1 minus depreciating 0.05 to the 11th power. So this is the same as when you put in the calculator, 30,000 times 0.95. So this is what shows that 5% decrease to the 11th power, which gives you that the purchase, the amount of land here, it's money, so you have the decimal, is approximately $17,064. Now, due to the decimal here, it actually ends up just rounding to this whole value here. So now go ahead and pause the video and then try these two U-tries on your own. And here we go. So now here, starting in the year 2000, 6.8 billion. So this is our principal. Now notice the rate of increase. So this is a growth, which means you were supposed to add. Here's our rate, 1.26%. So if this is a percent, divide that by 100 and you get 0.0126. This is the rate that's added to 1. What is the approximate population in 2020? Which means here, how many years passed? 20 years. So T is 20. So here we go. So you could put the billion, but I'll just put 6.08, and then we know that this is in billions. That's our unit. So A is equal to 6.08 times 1 plus 0.0126. Raise that to the 20th power. So here, what you should have ended up putting in your calculator is 6.08 times 1.0126. Raise that to the 20th power. And the population is approximately 7.8 billion. Then in the second, this equation was given to us. Decrease. So here, the initial amount, 850. So just maybe for practice, if the base is 0.92, right? We know that this is a decay, but by how much? What percentage? Well, if this is out of 1 or 100%, what is the percentage that got subtracted? 8%, because here I've got 1 minus 0.08, right? Because that's going to represent your 8% here. Subtract that, you get 0.92. So what was our T that you had to use? 5 years. So here, 850 times 0.92, raise that to the 5th power, and you get 500, about 560 whales. And then the last you try. So go ahead and pause the video and try this on your own. And here we go. So you should have noticed we're talking about increase. So this is a growth where you would add the percentage, right? So this is 1 plus the 3%, not 1 plus 3, right? So this is 3% or 3 out of 100, which is 0.03. So here our base would be 1 plus 0.03, which is 1.03. That's why the answer here is D.